Hello everyone, I'm Rajasri, Assistant Professor, Department of Electrical and Electronics Engineering, working at MLR Institute of Technology, Hyderabad. And in today's lecture, I'll be discussing choppers. Firstly, chopper. It is a device which converts DC to DC, that is fixed DC to variable DC, or otherwise it also converts variable DC to fixed DC according to our requirement. That means basically it is a DC to DC converter. Chopper is also called as a DC to DC converter. It either steps up the voltage or otherwise it steps down the voltage. And here, what are the various applications of choppers? Here, it can be used in DC traction drives, trolley cars, marine lifts, etc. Lifts, cranes, etc. And here, firstly, the efficiency of these choppers will be very high because of its fast dynamic response. I mean, the kind of the switches which we are making use of, the dynamic switching nature of these particular switches will be good. So that is the reason we can obtain fast dynamic response, and thereby efficiency is also high. And here, now let us discuss step down chopper with resistive load. And this is the basic chopper where a switch will be connected in between supply as well as load, and this switch we can make use of. It can be a transistor, it can be a GTO, it can be an IGBT, or it could be also a power MOSFET. So depending upon the application, we can make use of a suitable switch, and here we are making use of we are connecting this particular switch in between supply as well as load. And here this is a step down chopper. Firstly, the moment when we provide the base drive, that is for a transistor we usually provide the base drive, whereas for thyristor, in order to make it work, we provide the triggering pulse. And here, as long as we provide the base drive, the device will be on, and the moment when we withdraw this base drive, the device will be turned off. And here we are providing the triggering pulse right from this instant called 0. From 0 to delta T, here we are providing the base drive required by the transistor, and at that instant the transistor will be on. And when the transistor is on, whatever the supply voltage which we are feeding will be appeared across the load when the switch is on. That is, when the switch is on, because current is flowing through the load. This is the current which is actually flowing through the load. This is I0, and since current I0 is flowing through the load, voltage across the load will be V0 is equal to I0 into R. And this is the output voltage which is appeared across the load. And now let us verify the waveforms. The moment when we provided the base drive from 0 to delta T, and this is the output voltage with magnitude Vs. The supply voltage itself is appeared across the load. So that is the reason here V0 average output voltage waveform will be with magnitude Vs. And as long as we are providing a base drive, the supply voltage will be appeared across the output, and that is how we are getting the output voltage right from this instant 0 to delta T. And the moment it reaches delta T, what happened? We are withdrawing the base drive, and here there is no base drive provided for the transistor, and the moment when we withdraw the base drive, the transistor will be turned off, and that is how there will be no output voltage, because the transistor is off, and since it acts as off switch or it acts as open circuit, whatever the supply voltage which we are feeding will not be applied across the load. And that is how right from this instant called delta T to T, our output voltage is remained 0. And the moment again at this instant called T, when we provide the triggering pulse, the transistor will be on, and output voltage will be appeared across the load, and the cycle repeats. And if you see, this is the on period. This is the on period of the chopper from 0 to delta T. It is remain on, and the moment it reaches delta T, here since we are withdrawing the gate drive, our output voltage is remained 0, and this we term as T of period. And again at this instant from T to T plus delta T, transistor again it is turned on by providing the base drive. So that is all, and this is the output voltage which is having the magnitude of Vs, supply voltage. And then moving on to the output current, and if you see the output current I0 is equal to, it is given by V0 by R. And since this is resistive load, the output current waveform will be exactly similar to that of the output voltage waveform, except the magnitude. Magnitude is the only difference. And here, since I0 is equal to V0 by R, see, output current waveform is just similar to that of the output voltage waveform, only this magnitude will be getting reduced. Since the value of the resistor is given, the I0 magnitude will be getting reduced. That is the only difference. And here, this is the I0 waveform from 0 to delta T. Since transistor is turned on, when transistor is provided the base drive, transistor, since it is conducting and it is driving the current through the load. And as long as transistor is turned on, here we are getting the output current from 0 to delta T. And the moment when we withdraw the gate drive, at this particular delta T, the transistor is turned off, and thereby it acts as off switch or open circuit. Thereby there will be no current flowing through the load. And again, this instant called T, we are providing the base drive. That is how transistor is conducting again, and current will be flowing through the load, and hence the cycle repeats from T to T plus delta T. And if you see, this is a step down chopper. Coming to the V0 average for this particular step down chopper with resistive load, here V0 average, is equal to, the general formula we have is 1 by T, 0 to T, V0 of omega T, d omega T, where the limits are, if you see, previously we have seen chopper was been conducting from 0 to delta T, and with the magnitude V0 is equal to Vs dt. So here I am bringing out constant in order to integrate Vs by T, and this becomes T with the limits 0 to delta T. Substituting the limits, upper limit minus lower limit, we get delta T minus 0. And here we can cancel T and T such that our V0 average expression for single phase step down transformer with resistive load will be delta Vs. This is V0 average expression. And similarly, V0 RMS expression, in order to derive V0 RMS, we have a general formula, that is 1 by T, 0 to T, V0 square of omega T, d omega T, where 1 by T and limits were same. 0 to delta T, it has been conducted, output voltage we have got, and where V0 is equal to, it is with magnitude Vs dt, and here bringing Vs out constant, Vs by T, and integration we get within the limits Vs square, this is Vs square, and integrating, substituting the limits Vs square by T, delta T minus 0, and here Tt gets cancelled, and this is whole to the power of 1 by 2, and here whole to the power of 1 by 2, where this is Vs under root delta. That is, V0 RMS expression is equal to V under root delta Vs. This is the V0 RMS expression for step down chopper with resistive load, where delta is nothing but duty cycle of the chopper, and it is given by the formula delta is equal to T on by T, where T is the total time period. It is given by, it includes on period plus off period of chopper, which is the total time period of the chopper. And then coming to the chopper control techniques, here we have time ratio control techniques. That is, we can maintain constant frequency operation, or otherwise we can obtain variable frequency operation. That is, constant frequency operation is here either T on as well as T off, both will be varied such that frequency will be remain constant. The total time period will be remain constant. That is, in constant frequency operation, here we will vary T on as well as T off such that the total time period will be remain constant. That means frequency will be remain constant. This is constant frequency operation. Whereas in variable frequency operation, either T on will be varied, keeping T off constant, T on will be varied, keeping TF constant, or otherwise T off will be varied, keeping T on constant. This is how we obtain the variable frequency operation. These are the chopper control techniques which we have. And now moving on to the upcoming lecture, we'll be discussing step down chopper with RL load. Thank you.